Hey, so after I posted my last video about hacking the new Nintendo Game & Watch, the people on Twitter, in the YouTube comments, and even my friends made one thing very clear. The Game & Watch has to run Doom. And so, motivated by this, I got started. And wow, did I underestimate the required effort. But now I'm excited to show you the Game & Watch running Doom. It's not yet performing great. I had to remove a lot of textures, sound had to be disabled, the screen resolution is slightly reduced, and there's still a lot to do before you can enjoy the full game. But it's running and it's playable. Awesome. And so in the next few minutes I want to give you a brief overview over what it took and what the challenges were, and what you can expect in terms of homebrew on the Game & Watch in the future. Now, in the last video I already mentioned that the next step that needs to happen is to dump the full firmware of the main processor, and we managed to do just that. On Monday afternoon, I teamed up with Konrad Beckman, another hardware hacker from Sweden, who does really interesting hardware hacking and electronic stuff. And you should go and follow him on Twitter right now. We bounced a couple of ideas back and forth, and eventually found that the original Game & Watch firmware loads a bit of ARM code from the external flash, in the same way and with the same encryption as the NES ROM you saw in the last video. After some more reverse engineering, we were able to load and execute a tiny piece of code that allowed us to dump the original firmware from RAM. I'll go into more detail about this in a future video, and we will soon be releasing scripts so you can dump and back up your own Game & Watch, and also get started with building custom homebrew for the device. Next it was time to get the hardware running with our own code. This is not as easy as it might sound. While the datasheets for the STM32H7 and also for the flash are readily available, we had to reverse engineer all the pin connections on the device and use a logic analyzer to sniff and then reproduce the SPI commands used to initialize the display. Eventually we had the full hardware working. Display, buttons, sound, and even the flash chip were supported, which Konrad immediately put to good use by using the Game & Watch to rickroll people on Twitter. Now that we had a basic working project, I could start porting Doom. I started by looking around for other ports of Doom for similar processors, and I found STM32 Doom by Floppis, a port of Chocolate Doom to the STM32F4. While it may sound like it would be easy to port this over to the STM32H7 used on the Game & Watch, it unfortunately wasn't. STM32 Doom is built for a board with over 8 MB of RAM, and uses a USB stick as a data storage for the Doom files. On the Game & Watch, however, we only have 128 KB of integrated flash, 1 MB of slower external flash, and only 1.3 MB of RAM. So obviously there was quite a lot of work to be done. Now Doom uses a file format called WAD, where's all my data, as the package file format for all game resources such as sprites, textures, levels, and so on. The original Doom 1 WAD is 4 MB in size, and given that we only have roughly 1 MB of storage, in which we also need to fit our code, the size of it had to be massively reduced. After some research I found a mini WAD, a minimalist Doom iWAD that replaces all the textures with flat colors and all the enemy models with simple outlines and so on. And so it wasn't pretty, but wow was it tiny. After compression with a tool called WAD Pointer, it's barely 1/4 of a megabyte. Perfect. I started the port by copying all the Chocolate Doom source files into my basic hardware bringer project and just fixed whatever compilation issues came up. In the end I had to implement a couple of features. A custom file loader that would load the WAD file directly from a large buffer instead of using file system functions, a custom frame buffer support, Game & Watch button support, and a lot of little things. I also had to remove a couple of features, such as sound support and the infamous wipe effect on startup, just to reduce the memory usage of Doom. And eventually it was compiling and flashing, but it was far away from actually running. It would crash pretty much immediately on start because of memory issues. So I had to look at the RAM usage. We have a couple of ranges that are a must-have. We have the LCD frame buffer, which by itself already takes up 154 KB. We have 160 KB of initialized game state, 320 KB of uninitialized data, and a large area for dynamic allocations. And exactly these dynamic allocations were a large issue. The game has its own allocator, but also uses malloc and calloc. The common use of allocating memory and freeing it immediately quickly fragmented the memory, making it impossible for the game to allocate new, larger memory areas. I fixed that by replacing a lot of the dynamic buffers with statically allocated buffers, which also had the advantage of making it easier to move data around the different RAM regions. It also had the advantage of giving better error messages on memory consumption at compile time. And eventually, after a lot more testing, fixing, flashing, compiling, coding, waiting, I got it. Doom running on the Game & Watch. Added terribly bad performance. It took multiple minutes to load, then multiple seconds per frame, and it was just a disaster. Luckily, Conrad came to the rescue. He figured out how to increase the CPU and flash performance drastically, and after merging his changes into my codebase, Doom suddenly became playable. And here we are, with Doom running on the Game & Watch without any hardware modifications. And you can find the full source code linked in the description. Now, this is just the beginning of Homebrew on the Game & Watch, and we are currently working on building a basic project for others to start building Homebrew for the device. If you're interested in following that journey along, please subscribe. As always, thank you for watching and see you on this channel again soon.